I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on the AP Physics 1 exam, the 2024 FRQs. This is question 4, the paragraph length response. So in this video, we're going to talk about the AP Physics 1 2024 FRQs. This is free response question 4. This is the paragraph length response. So in this question, we're given that a small sphere as position A is pulled back to a small angle, and the reason this is important is it's the small angle approximation, and the small angle approximation means that the period of a pendulum equation works. As the angle gets longer or larger, that means the period of the pendulum equation breaks down. So it swings from position A to position B, and the Earth is not part of the system, so it does work to cause it to move from A to B. Then it's taken to a different planet, planet X, and repeated the process. And the work done by Earth is WE, and the work done by planet X is WX. And a couple things that gives us about planet X is that it has the same mass, but it has a larger radius, which is going to be important. We want to justify why WX is less than WE. The work done by planet X is less than WE. Let's start with the work equation. Work's equal to force times distance. Well, the distance that we're doing work is each planet is just this distance delta y. So we can change work equals FD to work equals F times delta y. Well, the force that's causing it is the force of gravity. And we know that the force of gravity is just m times g, so that means the work is just going to be mg delta y. Now, the mass of the pendulum bob is constant. Delta y is constant because the angle it's pulled back is the same. So the only thing that is going to impact this is the acceleration due to gravity. So the acceleration due to gravity is the piece that we need to figure out what happens. So what we can do is we can set mg equal to the universal law of gravity. The mass values are going to cancel out, and that leaves us with the acceleration due to gravity on a planet is dependent on a constant, capital G, the mass of the planet, and the radius of the planet. Well, what do we know? The mass of planet X is the same as the mass on Earth, which means G would be the same, but the radius is greater than the radius on Earth. So the bigger the radius, looking at that equation, means the smaller the acceleration due to gravity, because we're dividing by a larger number and squaring it. So the acceleration due to gravity on planet X is going to be smaller than on Earth. So if the acceleration due to gravity on planet X is smaller, that means the work done on planet X is going to be smaller than the work done on Earth. Now, the paragraph length response question, this usually is worth 1 or 2 points. I'm going to guess that it's worth 2 points in this case. Now, the scenario for the paragraph is that we're given this same scenario, except we change the string to something that can stretch. So it's slightly elastic, so it can stretch, and the length can vary depending on the tension that's applied. So we take this and we swing this back and forth on Earth, and we're going to compare that to planet Y, a different planet, where planet Y now has more mass but the same radius. And we're going to compare the period of the oscillation on planet Y to that on Earth. So with the string being able to increase or decrease, that's going to be a factor in our writing of the paragraph. And we're going to compare why the period on Y could be bigger and why it could be smaller. And the information that I've underlined is that the mass is larger on planet Y, but it has the same radius. So what we're going to do is to formulate our responses, we're going to look at a set of equations. So we're going to look at first the equation that we derived for part A is that G is equal to capital G m over r squared, which is going to help us figure out the G value. And then the period of a pendulum equation is equal to 2 pi squared of L over G. So our factors that are going to impact the period of the pendulum are the length of the pendulum and the acceleration due to gravity on that planet. So we're not going to write a paragraph. We're just going to give bullet points, and you could write the paragraph as you could. Hopefully you wrote it in a paragraph form, because that is one of the points, is following the guidelines that are given in the College Board's paragraph length response. So the first bullet point is that planet Y has a larger acceleration due to gravity, because it has a larger mass with the same radius. So if the radius is the same, we're dividing by the same number squared, but m is going to be bigger, giving planet y a greater acceleration due to gravity. So in the period of a pendulum equation, as g increases, the period decreases. This is why ty could be smaller than te, because the acceleration due to gravity could increase more so than the length that the pendulum increases with the elastic part of the string. Now, the period is also dependent on length. As the length increases, so does the period. And the elastic string may stretch beyond a length to compensate for the increase in the acceleration due to gravity. This would cause a larger period with a larger length. This means that Ty would be larger than the period on Earth. So these are the 4 bullet points that I put together, which should give you all 4 points of the content for the paragraph, and then writing it as a paragraph with following the guidelines laid out by College Board is going to be the remaining point of the 5. Now they could probably do a 6 point and make part A 1 point, but usually it's broken down. Part A is 2 and part B is 5. So this is the paragraph length response on the 2024 FRQs. Question 4. I hope this was helpful, and I hope you have a great day and an even better tomorrow.
If you found this video helpful, click the like button down below and subscribe to my channel, Happy Coaches, and follow me on Instagram and Twitter at Happy Coaches.